Okay, so yeah, it's a little uncommon without speakers, but I guess you hear me. So welcome to my talk about LibreOffice as a web component. My name is Moritz Duge. I work for the company Allotropia. I would say we are pretty much a European company, but our post box is based in Germany. Yeah, let me take you through this journey. So let's talk about a little bit about Office suites in general. So myself, before I started working as a LibreOffice developer, for me Office suites were mainly a thing I used to create my bachelor thesis, or maybe to do some small spreadsheets to keep track of my vacation days and things like that. But it turns out actually a lot of organizations use Office software as a customizable software component framework and embed them into their applications, connect them with databases, and do all sorts of amazing stuff to get their workflows running with Office suites. Things like order administration, warehouse software, accounting, bookkeeping. That's things being done by companies. Actually, many years ago, when I was a very young student, I did the administration for a dentist, and he had all his patients' data in such a kind of application, which used, I think back then it was Microsoft Access in the background to handle all the data, and that's things people do with LibreOffice, and yeah, it's actually a very interesting use case. So Office documents in this sense are kind of like programmable documents. You can use macros, you can use spreadsheet formulas, and you have tons of powerful features in an Office suite which you can use to easily build nice applications based on this. Charts are an important thing here always to mention. Yeah, and when you run LibreOffice on a desktop or maybe on a server, you have a powerful API you can use to control LibreOffice. It's the Uni API. You can do all sorts of things through the Uni API, but you may have a problem when you start moving your applications into the web and having web applications. And yeah, that's actually the thing where I like to take you on a journey about this. So there are quite a few web office solutions. One is sitting over there with that nicely colored T-shirt, and there is also a lot of proprietary stuff going on where you will be bound to certain vendors, and that's not nice. We don't want to do this proprietary stuff. And when you use those proprietary cloud services, you are bound even closer to those vendors. You can't even run this stuff on premise. That's a very hard vendor dependency. Yeah, usually you don't want to do this, and maybe you're not even allowed to do this because the law says you must keep the data in your organization. So what do? We can move actually LibreOffice into the browser. So it's running on the client, inside the web browser. It even keeps running when you cut off the Wi-Fi connection because it's kind of running inside the JavaScript engine of the browser. So that is called WebAssembly. If we run native C++ applications inside the browser, it's not really JavaScript then anymore, but something that runs inside the JavaScript engine as native code. And what we have developed is a library which attaches to this WebAssembly environment where you can run LibreOffice inside and gives you a nice JavaScript API with which you can script the LibreOffice, how it behaves inside the JavaScript environment, exchange data, control what LibreOffice does there, and connect it basically with your whole web application you have running inside the browser. It's mid-open source licensed. Surely we are at an open source conference, and yeah, and the nice thing about this, you only need a very basic web server. It only needs to serve a few static files, and there's not much going on the web server actually, because all of the magic happens in the browser, and the browser is providing the environment that's being used here. We are currently at about a little less than 50 megabytes of data that needs to be served by the server, the application, the actual binary code of the application, and a file with some assets the application needs. But this is also cached by the browser, so you won't really realize 50 megabytes going through the line once you have this loaded one time. Yeah, and it's quite high performance because this WebAssembly is a specially optimized system which all the web browser vendors like Firefox, but also Chrome or Microsoft agreed upon. and that works very nice. Yeah, so a short digression to get a little more technical here. So usually JavaScript runs inside something the browser vendors call the main thread. So it's not concurrent, it's one thing happening at a time. You don't use multi-core stuff. That's not good. You can't use the full performance of the system. So usually you want some concurrency, some parallelization, and web browsers provide something which is called web workers to do this. But it's not really like threads, although the term main thread, it's more like processes, because there's a very strict memory isolation between those web workers. You can exchange data. There are like two main mechanisms. One is more like message passing for small amounts of data for just handling the control flow. And the other one for large amounts of data are shared array buffers. And with shared array buffers, you can basically turn them into something which is more like threads, what we need for a C++ application, which was developed for a standard operating system where you have threads. But shared array buffers have some problems, and I'll come back to that later. But basically with this, you can get a very nice performance and you can use all the CPU cores of the system. So I'll switch to my live demo now. Yeah, so here we have a LibreOffice running inside the browser. You see this canvas frame here. And inside the canvas frame, there's a LibreOffice running. There is a typical template letter you can use in LibreOffice. It's actually just one I picked from the standard repository of template letters LibreOffice has. And now I have here a very basic example of what could be an address database application you have in your organization, which is providing an address database through some web interfaces. And the nice thing is now that if I manage to move over my mouse, yeah, I can just select stuff from this database and fill the letter with this information. And the JavaScript interacts with LibreOffice and tells LibreOffice where to insert this data. This is a very nice way how we can integrate web applications with this, like what used to be a standard desktop application. Just to give you a little more insight into how this happens, I have a small snippet of JavaScript code here. I unfortunately can't increase the zoom, I think. But yeah, it's basically a small snippet of JavaScript code where I use this JavaScript API. I have here the Zeta.js API to tell the controller object of the LibreOffice application to do some changes, and I can even fully customize the UI through this. So here I can just show the menu bar, which we have hidden for this example because it's not needed and makes everything more streamlined when it's hidden here, but we can also show it again, and that's how we can customize a lot of the UI and make it fit into the web application we have here. So back to the presentation. A little more about the example. Okay, maybe I switch back for a second. You see here is even buttons to download the document as ODT or PDF file. You could save them to any other web resource instead of that, but as an example here, we offer the possibility to download them. And this is how this is actually being done. So that's code which is running inside the process, the web worker, where LibreOffice is running. And this is actually the Zeta.js code, which is instructing LibreOffice to store the document, which is being shown at the moment in a file. This file is now simply named /tmp/output here. There are a few properties, very basic stuff, telling LibreOffice to save it as a PDF file, not as some other kind of file. So that's what's happening in the web worker code, and that's basically what you need to tell LibreOffice to store the file. And the next thing which happens is now happening in this main thread of the browser, where like the standard JavaScript code runs, like what you usually do when you do JavaScript development. And here's like a virtual file system object, which can access the files that LibreOffice stores in memory. And here we can read again this file /temp/output and store it into a standard JavaScript blob object, and then use this with pretty normal JavaScript code to generate a download. And yeah, the user gets a standard download pop-up and can store the files somewhere. Yeah, nice thing about this is actually that you can do a whole range of applications, and these are just a few examples. The example I just showed you. This is another example where we actually use a spreadsheet to plot some data. So when you run this inside the browser, you can put in a URL of a website, and it will send TCP pings to this URL, measure the latency, and put the data in a nice spreadsheet. And we can use all the features of LibreOffice spreadsheets here. I have another example, a little different version of this demo. Here you see that it's actually really a spreadsheet which is working there in the background. And here I have opened LibreOffice in the foreground, and you see it's just a standard spreadsheet. And if you want to change something in there, maybe switch it from blue to red color, you can just do that in LibreOffice, store the file back to the web server, and you have changed this part of your web application. Yeah, so if you like to see more of these demos, have a look at zetaoffice.net, where there we have a whole range of those demos. We have also pre-compiled Lovo binaries, but everything is open source. You can get it all from either the source repository of LibreOffice, and the other parts we have a GitHub repository for, where the mid-licensed code is being stored. But sometimes compiling LibreOffice takes a little bit more time than you have, so we have some pre-compiled binaries. Yeah, stuff like finding and replacing text, a version with a fully fledged LibreOffice UI in a browser. Maybe that's not what everybody wants, but just to see it. Yeah. So a little bit more about the technical background which we had here. So this is pretty much cutting the edge of web browser development. So this WebAssembly thing, it's existing since 2017. That's when the web browser standardized how to run C++ code and other languages like Rust inside the browser. Emscripten is something that came up in 2012. Emscripten is what we use to embed the C++ application in this WebAssembly environment, because the application actually thinks it's running on some kind of Unix operating system, and Emscripten is like mocking up a basic Unix API for the application, and also providing this like virtual file system I talked about before, where the file is being stored temporarily. We even made a few upstream patches to Emscripten, for example, to switch those web workers for this concurrency, to make this more nicely inside the browser, so you can nicely debug multiple threads going on there. Yeah, with Safari, it's always a little bit hard. Firefox is actually quite fine. There are some bits which are better in the Chromium world at the moment, but I think Firefox will catch up there. It's nothing undoable, I would say. And but the Safari is currently a little bit difficult here. Yeah, and as I told you, we also use this web workers feature for concurrency. Yeah, that makes it just much faster than standard JavaScript. Problem is, I mentioned the shared array buffers before to share memory between the web workers, and turns out shared array buffers have a problem, and this problem has to do with something I totally didn't expect it here. So that's CPU bugs. So you might heard of the CPU bugs Spectre and Meltdown, and for me this was always something maybe the operating system has to care about, or maybe I have to do some BIOS updates to get new microcode into my CPU, but I never expected that it actually has to do something with browsers. And it's not that websites can, or JavaScript code of websites can break out of your browser and hijack your actual system, but it's that JavaScript code running for one website inside a browser can hijack JavaScript code which maybe runs in an iframe which serves another website. And here the browsers do some kind of process-like isolation between those different JavaScript contexts, but they don't use the actual process feature of the operating system and the hardware's memory management unit for this, but they implement a known memory management system for this inside their process. And for this, they don't have any mitigation for Spectre and Meltdown. And it turns out you can use shared array buffers to do some very precise timing and run this kind of side channel attacks, which Spectre and Meltdown are known for. Yeah. If you like to go deeper into this, look for shared array buffers, and what the browser vendors invented to somehow get around this is called CORS. It's basically based on the principle that you can't load any security relevant data from other websites and put it into the same context as your JavaScript code, and by this it's then fine that those CPU bugs exist. Yeah, I talked a little bit more about this at the LibreOffice conference. Check out my talk from that conference if you like to know a little bit more. Yeah. So at the end, I'll have a small outlook at which things we are currently looking. So an important thing for us is always to improve the developer experience. We are starting to support web frameworks like Vue.js. We already have a small demo for that. A thing we'll also like to look into is TypeScript, just because that's how you can write much better web applications than with plain JavaScript. It's very common nowadays among web applications. We'll have specialized production and debug builds of the binary compiled C++ code, either with debug symbols and logging and stuff like that turned on, and on the other side optimized for size and speed, also to improve the mobile experience. So that's something where we are currently looking into. Apart from that, I just say, please share your ideas, whatever you are interested when you're looking at this. We'd like to know about that, and then we'll see what we can do there. Yeah. So thanks, and any questions? Do we have a little bit of time for questions? 2 minutes. Okay. Yeah. I just give you the microphone.
Do you have any tools to recommend for doing the debugging? You know, the WASM.
Yeah, debugging, that's kind of what I just said, where Chromium has a small advantage at the moment. So the debugger tools for Chrome are quite nice. There's even an official add-on by Google, which you can install in Chrome, where you get debugging abilities for C++. So you can even go into the C++ code and debug that. You can always debug the local LibreOffice application for your operating system instead and try out what happens there, because it's the same code. It's the same thing happening inside the browser as what's happening on your desktop when you run LibreOffice there, which is a great thing, because it means that we can have every feature we can have on a desktop also inside the browser. But yeah, basically use the browser's debug tools, and at the moment I would recommend Chromium for that, but I guess Firefox will catch up soon there.
Any other questions? No? Well, thank you.
Thanks.